Hello everyone, I am Gustav. For my first video, I wanted to show you how to set up SFML with MingW compiler, CMake, and Git Submodules. In this tutorial, I will be using VSCodium, the telemetry-free VS Code, as an IDE for C++ development to set up a project with SFML. Now I will stop wasting your time and get right into it. Firstly, you will need VSCodium or VS Code. Depends which one you like. I don't really care, they're both the same. Now, after that, you want to make sure that you have the C++ extension pack as well as the CMake extension installed. This just helps with the IntelliSense and project building. It helps a lot in the long run. After that, you have to make sure that you have a working CMake executable. I am using CMake version 3.27.0-RC3. After that, you want to make sure that you have a Git executable. This is also really necessary because we have to use Git Submodules. If you plan to use SFML without Git Submodules, you can maybe lose the Git. Then the most important of it all is the C++ compiler. Now I will be using the MingW GCC. That's not the right one. It's the MingW GCC 13 compiler. It is the one listed on WinLibs as MingW-W64. I really do recommend this compiler. It really works. So make sure you do not have the UCRT runtime version. This one does not work. I have tested it. Maybe if you know how to make it work, let me know. But the MSV CRT works like a charm. So you can just grab the zip archive of any of these, preferably the Win64, but if you're running an older machine, 32 would work just as fine. Then we can start creating the project. So now head to where you want to create your project. I'm just going to create mine on the desktop, create a new folder, and call the project what you want. My SFML project. Now this is only a raw folder. You will not be using this with outside of the IDE. So now we can open VSCodium. Now it would look something like this, and then you can head to File and select Open Folder, or click here, or optionally press Ctrl K and Ctrl O. This will open a dialog to select a folder. Mine was located on the desktop, and I'll just select it. Great, now you've got your project folder inside VS Code, and now you can start working on it. So the first thing we're going to do is initialize the Git repository. It's not necessary to publish the branch because I'm not going to be uploading it to GitHub right away, maybe later, but now it's still fine if I just use Git without it. Now you might not see this Git folder, but trust me, it is there. I just turned my settings so I can see all the visible folders. Now, next step is we're gonna create a folder. This is where all our external libraries is gonna go. I'm just gonna call it external. It's fine like that. This is exactly where I'm gonna store the SFML submodule, and it just makes everything a bit more neat. So yeah. Next, we can quickly open a terminal, you can open a terminal by pressing Control and the button right next to the number 1 below Escape. This will open the terminal here and below, or you can just go to here and locate this to this button. This will also open a new terminal. Now, first thing we want to do is go to the external folder. We can do this with change directory or CD, and then call the folder, press tab, it should autocomplete, and just hit enter. If you never worked with a terminal, don't worry, this will be rather simple, but I think at least all of you that is watching this video is probably going to know what a terminal is. So now we're going to run the command git submodule add, and we're going to pause right there. Now we're going to go to our Chrome or your browser, any browser that you think you like, and locate the GitHub page for SFML. Now this is the source code for SFML. It is latest release, nightly build. It's even before the snapshots. This is the most updated version of SFML that you can get. Now we are only going to copy the HTTP address, so we can just hit that copy there, and now it's in our clipboard, and we can just paste it there and run the command. Now what this is going to do, it is going to download the repository into this external folder and create a submodule. Now that it has completed, you can locate to the external folder, and then you'll see a folder named SFML, and all the files that was listed in the GitHub repository has been copied to your local machine. Now the nice thing about Git Submodules is that you can automatically update your repositories from here. I'm not sure if the built-in source control works with the submodules, but I usually just use Git Submodule, then update, remote, and recursive. It works like a charm every time, but yeah, you do not have to update your submodules, it's fine. Yeah. Now that we have the SFML build, we can start by creating our directories we're going to need later on, like the source directory. This is where all your code is going to go, your include directories, all your header files, and we're also going to create our CMake file. Now my CMake has auto completed my compiler, but here you can see my compiler list. Now I'm going to use the GCC 13.2 x86 underscore 64-W64 MingW compiler. Now this is the one I described. It's from WinLibs, the MSVCRT runtime. It has to be this runtime. Now this is I think this is the latest version at the moment, but I'm just going to select that, and now you will see it will create a build directory by default. Now mine creates a debug directory as well. You can change this in your settings. It's so that it defaults to the build type you are using. So I'm using debug, so it creates a debug folder, and this can be changed right here in the CMake tools setting right here. This is what I'm using, and this is what I'm going to be using for the whole video. Now to continue, this is our CMake file. We're going to start by defining the minimum version, the project name, Then we have to start with the most important thing. It is by setting whether or not you're going to build it statically or not. So I think it's SFML. Let me just check. SFML static libraries. Now you can either set this to false or true, depends. Do you want to build statically or dynamically? In this tutorial I will show dynamically because dynamically is the more difficult one. Then after this, it is very important to also define that you want to build shared libraries. Like I said, if you are going to build statically, it's not needed to build the shared libraries, so then you have to turn this to false. Now we're going to start by adding our executable, and you can call this whatever you want. You can call it the same as the project name, or like I used to do, is probably bad practice, but I usually just use the project name variable. It defaults to this value. It's just for simplifying the code a bit, so I can just focus on writing simple readable code. That's it. Now we are going to need some sources for this. This is why I created the source directory. The easiest way that I usually use is just call the file and then glob and give it a variable. Sources is fine, and then call directory. Now what this is going to do is it's going to search for every C++ file, every file that ends with a .cpp in the directory src, which is our source directory, and it's going to store it in the sources variable. Now to access these sources is going to be really easy. We just, like we access any variable in CMake, just add the $sign and then the brackets and call the variable. Now at the moment it's going to yell at me and say I didn't give it any sources, and it's completely right, I have not. So now we're going to go and create our main file. We haven't done anything yet with C++. This is only just to show that it does work. So just create the main function, and when I configure this now, it should be all fine. Now that we've created the executable, we can create a link to our include directories. The link I first want to create is to our include directory. This is the where my program's main header files are going to be located. You don't have to do this, you can use the relative path system, but this seems to work best, so you can probably just use that. Now we're going to start and define just a small comment and show this is where we're going to store the code for the SFML library. Now we're going to start by adding the subdirectory that's located at external SFML. Now what this is going to do is it's just going to add the CMake file that is in this directory right here to our current CMake file. That is how we're going to, what is this thing's problem? Oh, I have to give it either public, private, or interface. I usually just use private, so sorry, this is the add subdirectory. It just adds the CMake file to this CMake file. Now that we've added that CMake file, we can link the include directories for SFML. This is very important, otherwise we won't be able to use any of the example code. We have to change all the paths to the include files. It's just a headache. So this is really simple to set up. Just call your target program here. It's the same everywhere. then call private or public or interface, which one ever suits you the best. Then we locate to external, SFML, and the include directory. This will include all the SFML header files, so we can access them from inside our main CPP file. Now we can link our libraries. This is important because we cannot just have header files without any code behind it. So we're going to add the library's source code to the project so it doesn't yell at us. Now I haven't tested this much, but I have seen it seems like public is better than private here. I don't know why I got some funky errors previously, but you can try private, doesn't really matter. Now, the libraries that we need to link are all located within here. So if we go to the CMake panel and go to the SFML section, then we would see there's like 6 different modules of the library. Now we want to import probably all of these. You don't need to import all of them. I'm just going to show you how to import all of them for future reference. So then we're going to call SFML. I'll just copy that for repetitive sake. SFML audio is the first one. SFML graphics. SFML main. SFML network. SFML system, SFML window. So now this will link the library from the whole library from all the modules. So now we don't have to worry if we have the source code or not. Really important, is very helpful if you're getting undefined errors. You have to go check these linked libraries. So this is optional, but this will ensure that the dynamic libraries that are going to get built is going to be copied right next to the executable. Then we do not have to do it ourselves. It just saves a bit of time, and we don't really need to do it, but we can. It's not a big deal. Now I'm just gonna add this comment. Now what this command is going to do, it is going to run a command from CMake and also copy a whole directory to another. Now I'll show you exactly how to write this. So first you have to reference your target. This is our executable we defined up here. Next is our command that we want to run. Now the command we want to run is called CMake, but we're not going to write it like that. We're going to access the variable inside of CMake that is called CMake command. Now this is not the full command, so now we have to add the parameters of -e. This is going to tell CMake to execute a function, and the function we want to execute is copy directory. This is built into CMake, so if I quickly run in a command prompt CMake -e /how, this will list all the built-in functions that CMake has. Now the one we're going to use is copy directory. Now you can see the input is the directory we want to copy. Then we state with the destination key, and then add the destination after the key. Now the way we do that is, first argument is the directory we want to copy. Simply, this is our output directory for our libraries. Now, some compilers might be different, but mine outputs it to the binary directory. So this is the build directory or the debug. Wherever these files get output, this is your binary directory. Then slash external slash SFML slash bin. Now I can show you where these files are going to be located. External SFML bin. That is where these dynamic libraries will be output. Now after we have specified the input files, now we can specify where these files should be copied to. Now I want to copy it right next to the executable, so this will be in the binary directory, and this is exactly where our executable will be output. It is right here within the build folder, and then the debug, and then your executable will be here. So now these libraries we've linked are going to be copied from this external folder to right next to the executable, so we do not have to worry about ever searching for a DLL or any of that nonsense. So again, like I said, optional, but it's really handy just to save some time. Now this is our CMake file. It is what we're going to be using for this tutorial. It is really simple, except for this last bit. Might be a bit complex for me as well, because I haven't been using CMake a lot. So next we want to get some code. We have to test if this actually works. So we're going to go to our browser. Then this is the official SFML website. You can just go to the start tutorials, the tutorials for 2.6. 2.6 is the latest release, but we are running a version that is even newer than the release version, so some things might be changing, some might stay the same. I'll show you an example. So the closest one we can get here is probably the MingW, so I'm going to click on this one. I'm just going to copy this code. This is just test code. You don't have to know what this means. Now we can already see we have an error. Now this is not an include error, although it might seem so. It's just a change in the files. Now the change here is when we call the function for SF render window and give it a name and then call video mode, the parameters for video mode changed. So it used to be two integers after each other, but now it's a vector of unsigned int, and we can see that with the U there. But this is a simple fix rather, so you do not have to worry. Some things, like I said, some things will change, some things might stay the same. So now we're going to call this is the namespace, and call the vector to unsigned int, and now everything should be working. Like I said, it's because this is a bit of an older version. This is the newest version on the market. Now that it's all built, I want to quickly change one thing. So if you're going to go to this source control, you can see we're adding like 170 files. Now the reason we're adding so many files is because we're actually including this build directory. Now we do not want that, because we don't want to ship our builds as with our source code. That's just wasting space. So now we're going to add a git ignore file. Now all this file does is just tell Git, okay, ignore that build directory. So you can see mine turn gray. I'm not sure if that's a default feature, but now we can see we only have 5 changes, which 2 of them are actually the submodule that we added at the beginning. Now you can commit these or do whatever, but first I'm going to test if this works, so stay right with me. We're going to hit build. As you've seen, it built quite quickly. It should be quite fast. It's a rather small library actually, so it would be fine, but if yours take a bit longer, it's fine. Now we can hit the run button here at the bottom just to see everything has been built, but now we're going to run it. There we have it. Our window with our tutorial looks the same as in the website. So now we can see our SFML is working correctly. Now we can make sure this is running from the dynamic libraries by just opening a command prompt, locating to the folder that we have created, and then here we can remove these files, just move them any other directory for now, just to test if they are working. And the best way to just do that is just to call a function, just to call the executable within a command prompt. But make sure you enter the build and debug directories. As you can see, it immediately gives us an error. It doesn't find a DLL. It's not the actual one we've removed, but I don't know, that's probably a bug. Then we can also see it needs SFML system, which is this one we just removed, and SFML graphics, another one we have removed. Now we can immediately see it's working because without these dynamic build libraries it doesn't run. So it is dynamically built. I have struggled to find a way to do this, but so when I found a solution, I wanted to make a tutorial because I want to help you guys. So I want to see if this even works with static libraries. So we can just delete our build directory just to get rid of any extra files that have been left over from the previous build. Now we can go up here and change this one to true and this value to false. Let it reconfigure, and now we can test it by building. Okay, it gave us a build error. Let's see what the error is. Oh, okay, so the error is just the copy command. Obviously it's not going to work because we have not created any dynamic libraries because we're statically linking. So we can try that again, hit the build command again. This time it should work 100% fine. Now if we hit the play button, we'll see that it works just as well. And I can make sure it's statically built by just looking at the directory. There are no extra DLLs, it's only the executable. Now I have to tell you the executable might be a bit larger because if you're statically linking, it has to compact all those files within the executable. So this one is 9 megabytes, which the other one would be less, but it will be in separate files. It's just sometimes a bit faster, well, not faster, it's just a bit lighter to import only some modules of a library. That's why dynamic is sometimes better. like SFML, it's a large library. Even if you're writing a game engine or a 3D renderer, it's probably best to just link it dynamically. But if it's just a small project, you can statically link it, it's fine. And as you think, it also works on Visual Studio. I'm pretty sure. I haven't tested it yet, but I'm pretty sure it will work on Visual Studio. So that's another bonus. So yeah, thank you for watching my small tutorial. I'm glad I can help anybody else that has came across this issue, and happy building with SFML.